Hello, everyone. Welcome to this episode of Eyes on Earth, a podcast that focuses on our ever-changing planet and on the people from across the United States and the world who use remote sensing to help monitor and study the health and well-being of our planet. I'm your host, Steve Young. Today's guest is Dave Johnson, a senior geographer with the U.S. Department of Agriculture's National Agricultural Statistics Service, or NASS. He is also a member of the Landsat science team. Welcome, Dave.
Hi, thanks for having me.
So, what can satellite sensors tell us about the health and well-being of crops on the surface of the Earth?
The satellites can tell us a lot about what's going on the surface of the Earth, and they can do it quite efficiently in a rapid manner versus you or I driving around in a car on a given afternoon. So we use the satellites to estimate the crop production. That's one of the major goals and mandates of the National Ag Statistics Service. And most of that information comes through surveys where we randomly contact farmers and ask them about their how much they've planted, how much they've harvested, what they're growing, where they're growing it, in addition to livestock and other types of questions. But the satellite remote sensing from sensors like Landsat gives us a different view of what's going on, and one where we don't have to necessarily bother the farmers who they're busy like we all are.
So you put out a Cropland Data Layer. What is it? Is Landsat used to make it? Tell us a little bit about it.
So the Cropland Data Layer is we call a geospatial product. So it's a map product that effectively at the end of the year is our snapshot of what was being grown in what field. So we are effectively determining with a fairly high degree of accuracy what fields were planted as corn, what fields were planted as soybeans, cotton, wheat, rice, you name it. And it's a snapshot of what we saw over the summer, really throughout the whole country.
In Landsat?
The Cropland Data Layer certainly leverages as much Landsat data as we can grab. But we love Landsat. It's been around for years. So we effectively download and integrate as much Landsat data over the summer. And more recently, we've also been integrating a lot of data from the European system called Sentinel-2. And that has really improved the revisit rates. And so now we really have 2 or 3 times more data than we did even just 2 or 3 years ago.
How does a satellite 400 miles up in the sky look down and say, well, that's a cornfield and that's a soybean field?
So the satellites are high up in the sky, and there's 2 ways we use them to determine or identify what type of crop is being grown within a given field. The first way is they collect data not only in the visible part of the electromagnetic spectrum, that area where we use our eyes and we can see a green field versus a black road or a red barn, but the satellites also observe in the longer wavelengths, so they tell us something about the chlorophyll content of those plants, the plant vigor, the plant health, and they can also tell us a little bit about the temperature of those plants. And different crops do respond differently. Soybeans is very, very verdant, we would say, in the longer wavelengths, so it's very bright in the near infrared, whereas wheat would be less bright in the near infrared. So that's the first way we do that. So the second way we get at it, there's the crop timing tells us something. A crop like winter wheat planted, say, down in Kansas, that is planted in the fall. It's very lush and verdant in April and May, and then it's harvested in what most of us would consider the middle of the summer. So it greens up and then it senesces. So we know that if we're observing the ground in August in Kansas and we see something green on the ground effectively, it cannot be winter wheat. So something like corn and soybeans, they are planted similarly in times, but corn tends to be planted earlier. So if we see a real green signature of reflectance from the satellite earlier in the season, that's more likely that's corn in say, South Dakota than soybeans, which tends to be later in the season. So it's the combination of both what we see in terms of reflectance and the timing of that reflectance. And furthermore, like a crop like alfalfa, it tends to be green all spring and summer and even into the fall, although it's cut multiple times. But so if we observe something that looks very green all year round, that may be an alfalfa field or hay. It's probably not a crop, which you would expect to not be green. So it's the combination of what we see in the electromagnetic frequency bands and also the timing of the crop and when the images are collected.
So how accurate are you?
So the accuracy of the Cropland Data Layer varies by the commodity type and the area within the country. Using corn and soybeans, they're the major crops grown in the United States. And over the Corn Belt, the Cropland Data Layer is very accurate for those. Probably at least 95% correct. So meaning if you look at the map and we have a field label as corn, there's a 95% chance or higher that is indeed a cornfield, and the same with soybeans. Now, a commodity that's much smaller in nature, where we have much less information about how it's grown, and let's say onions, for example, the accuracy of those are going to be much less. Maybe we only are 50% confident in those identifications of those fields. It also depends on the geographic scope and where you are, but in the Corn Belt, the I states of Iowa, Illinois, Indiana, we feel like that the remotely sensed information is giving us estimates or indications, as we call them, as nearly as accurate as the survey information. Now, we don't rely on just one or the other. We want all the information so we can get the very best. And there'll be areas where the surveys just outweigh. There's just so much more information on a given year. Or maybe we didn't get good satellite information because of clouds. But maybe there's an area where the survey information was thin or the conditions changed rapidly. And satellite imagery, like from Landsat, was able to give us a better snapshot of what's occurring in that area.
Would the only people interested in the crop data layer be those people who are planting and harvesting crops, or do groups outside of agriculture have an interest in it?
The Cropland Data Layer has a wide variety of users, and certainly anyone who's interested in understanding what was being grown where over the last decade, we have that snapshot. On the ag side, people might be interested in understanding crop rotation patterns. The Cropland Data Layer can help you understand what areas maybe have gone out of production or have come into production. We have people using the Cropland Data Layer to help model where wildlife would be. So maybe certain wildlife prefer certain crop type areas. People have also used it for rangeland style studies to try to understand urban extent encroachment, or how if crop fields are expanding into, say, grassland areas, or if cropland areas are diminishing and being returned to a more native state. Let's say you're trying to site an ethanol plant and you're trying to understand, well, where's the best place? You really care about where the cornfields are. So with the Cropland Data Layer, you can literally, say, I'm going to site my plant here and draw a boundary and calculate what's the estimated corn area within that. If you're trying to understand watershed impacts and what the ability of nutrients and how that loading impacts the river systems, the Cropland Data Layer is much more effective than coarse county level statistics. So it really allows you to isolate down to the watershed level of what is growing where. People might use the Cropland Data Layer for really atmospheric style studies. The different crops transpire different amounts of water. And so if someone's trying to understand what's going into the atmosphere, they might really need a really high level depiction of what's on the ground, versus what's vegetated and not vegetated, and what's corn versus soybeans. I could go down the list. It's a broad base, and it's not just one sector. It's the government types, it's the academic types, it's the commercial types, the educational groups, or it could be a family farmer who's just curious what is being grown where in their neighborhood, and they don't have the ability to get out there quickly.
Is there a certain website or something you go to see the Cropland Data Layer, or to even to see your NASS statistics?
Well, if you Google NASS, NASS.USDA, that'll certainly take you to the agency's website. In terms of the Cropland Data Layer, we have a website coined Cropscape. So if you Google Cropscape, that will highlight the website. Within Cropscape, we've set it up that not only can you visualize the data, but you can actually do some would say basic analysis, but some would say it's actually fairly sophisticated. So you can go in there and try to understand how the crops have changed through the years. You can do overlay analysis within the website. You can draw polygons if you want to calculate what the area of corn is over a certain plot of land, or maybe a watershed you have a lot of interest in. You can download the data through there if you have your own specialized software. We've got a cartographic tool, so if you want to print out what the crops are doing in your county, you can do that. And we oftentimes don't know what the uses or what people want to show at the end of the day, so we've tried to make it flexible.
We've been talking to Dave Johnson about his work using remote sensing to estimate crop acres planted and yields across the United States. It's been a fascinating conversation, Dave.
Thank you.
We hope you come back for the next episode of Eyes on Earth. This podcast is a product of the U.S. Geological Survey, Department of the Interior. Thanks for joining us.